Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth. Hey y'all, it's AP Physics 1 and we're Unit 4, almost halfway through. You gotta pat yourselves on the back. You're doing a great job hanging in there. That dynamics unit was not easy for some. Projectile motion wasn't easy, but you are almost on Christmas break probably, most of you watching this. And you gotta pat yourselves on the back. You have made it through half of the curriculum and we're proud of you over here at Physics with Beth and Beth, so way to go. All right, we are doing a collision concept problem. We've already have our video on momentum. We've already done our videos on impulse. We did our first video on collisions and how to do them. Now we're talking about this concept problem that comes up a lot. And they give you two cars, or carts, physics carts, and they give you these cards. They tell you before and they give you an after, and they even give you the picture. They don't even write it out a lot of times. That might be written out, but then you know to do the picture. All right, and they're going to give you choices. They're going to say, hey, about this collision, we want to know, is it elastic, inelastic, or not possible? All right, so we're just going to get started on this. We already know how to do this. The very first thing that you need to do to determine if it's elastic or inelastic or not possible is you've got to see if momentum is conserved, because all collisions in the world, the real world, momentum is conserved. So we know that momentum before or initial has to equal momentum final. I have two objects here moving before. All right, that means I've got two momentums. So you have to have, if this one were at rest, then you would only have one, and that's okay if it's at rest. But they're both moving, so both have momentum. So I'm going to call this cart 1, I'm going to call this cart 2. So it would be M1 V1 initial plus M2 V2 initial is going to equal, now I go to the after. All right, they're both moving again, so I have two momentums. So it's going to be M1 V1 final plus M1 V1, M2 V2 final. There you go. All right, now they're going to want to know if this is possible. Well, if momentum before equals momentum final, then it's definitely possible, and we rule out C. That's the first thing you need to do. There's no point in jumping to kinetic energy and seeing if it's conserved, if it's not even possible, that collision in the real world. So in other words, I'm looking for a number over here to equal a number over there. Conserved means stays the same. All right, I can totally plug and chug now. M1 is 4, V1 initial is 1.8, M2 is 6, and then here's where you gotta watch these directions on velocity. That is to the west, so that's gonna be a negative 0.2. That's a negative 0.2. And then that's going to equal actually 6. If you were to do all that and multiply that out, that's going to equal 6. Then I have M1 V1 final, so that's going to be 4. Watch that again, that's going west, so that's a negative 0.6 plus 6 kilograms times 1.4 to the east, positive. And that's going to be 6. 6 equals 6. And yes, it is possible. So we know this is not correct. It's at least inelastic. Now we have to determine if it's elastic. Well, in an elastic collision, the additional thing that's conserved is kinetic energy. All right, so I'm just going to go ahead and, I'll go down here. Kinetic energy before equals kinetic energy final. And a lot of times you'll see this is just K without the E. I'm just putting the E in just to make sure that you know I'm not talking about spring constant, which is also a K, although it's a lowercase k, but it's hard to tell on a dry erase board. So there you go. So I have two carts moving, so I have two kinetic energies. I have 1/2 mass 1 times velocity 1 initial squared plus 1/2 M2 velocity 2 initial squared equals final, and they're both moving final too. Both of them, so they both have kinetic energy. 1/2 M1 V1 final squared plus 1/2 M2 V2 final squared. All right, now I can plug and chug. Again, if it's conserved, that means the number on this side is going to equal the number on that side. Now I have 1/2, I'm just going to go ahead and put this in. 1/2 M1 is 4, V1 was 1.8 squared plus 1/2 of the 6, and that is a negative 0.2 squared. Don't forget the squares. It's really common to forget your squares on this. And it's just the velocity that's squared, not the whole thing. But what's going to happen is a negative times a negative is going to come out positive. All right, and on this side, if you were to do that ugly math, it's going to be 6.6. On here, I'm going to do it again. 1/2 mass of 4. My final is negative 0.6 because it's west squared. Don't forget the square. Plus 1/2. 6, and it is 1.4 squared. And that's going to equal 6.6. So now that we know momentum is conserved and kinetic energy is conserved, we can with confidence say this thing was elastic. And that is how you do that concept problem on collisions, on determining what kind of collision it is. Not possible, elastic, or inelastic. I hope this helped. I hope that you are using your momentum and you are plowing through this Unit 4, pun intended. If you like this video, please give it a thumbs up. If you're watching our videos, we would love for you to subscribe and learn more about our videos when they come out. And thank you for watching, and happy physicsing.